Hello all, welcome to the next video lecture of polyalphabetic and beginner cipher. Some do call it as a Vigenere cipher, some do call it as a beginner cipher. In the previous lectures, we have seen the concept of monoalphabetic cipher, we have seen the concept of Playfair cipher, Caesar cipher for converting your plain text into the ciphertext. These are all the substitution techniques which we are learning under the heading of classical encryption techniques. Now let's begin with the polyalphabetic cipher. Polyalphabetic cipher is considered as another approach to improve the security, and here the security is improved using multiple cipher alphabets instead of multiple letters getting encrypted at a single time, which is used to happen in the Playfair cipher. Now we can consider this approach reduces the spikiness of natural language text used by the Playfair cipher, which encrypts more than one letter at once. We consider the other alternative using multiple cipher alphabets in turn. This gives the attacker more work because many alphabets need to be guessed, and because the frequency of or we can say the frequency distribution of the alphabets is more complex, since the same plain text letter could be replaced by several ciphertext letters, so depending on which alphabet is used when. The general name for this approach is given as the polyalphabetic substitution cipher. These techniques have some features in common. It has a set of related monoalphabetic substitution rules as it is used. A key is determined which particular has one rule to be chosen for a given transformation. It uses a key to select which alphabet is used for each letter of the message. It uses each letter alphabet in turn then. And whatever the key we are using, when the end of the key is achieved, we have to again start from the starting of the key. So this is just the basic functionality of the polyalphabetic cipher, wherein we are replacing multiple cipher alphabets at one time instead of using two letters encryption which was there in the Playfair cipher. Now let's take an example of the polyalphabetic cipher, that is the Vigenere cipher. Vigenere cipher is considered as the simplest polyalphabetic substitution cipher. It effectively multiples the Caesar cipher. Caesar cipher is considered as the basic cipher of the substitution technique. Here the key is multiple letters long. As I told you that we have to make the length of the key same as that of the length of the message, and for that reason only we have to repeat from the start after the D letter in repeat from the start for the D letters in the message, because when the end of the key is reached, we have to simply start from the starting of the key. For that reason we have to make the length of the key same as that of the length of the message. If suppose 10-letter word is given for as a key, and the length of the message is of 30 words or 30 letters, and key has 8 letters, so we will have to repeat those 8 letters to make it 30 letters. That is, the length of the keyword should be same as that of the length of the message. And here for the Vigenere cipher, the decryption process is exact the reverse of the encryption process. Now let's see an example of the Vigenere cipher, how this polyalphabetic substitution cipher works. Here we just have, it takes an example wherein we have a plain text. We are discovered, save yourself. This is one plain text, and this plain text has to be converted into the ciphertext because this plain text has to be transferred over the network. and here the given keyword is deceptive. So if we calculate the letters in the keyword, they are 9 letters, which is less than that of the length of the plain text message. And for this reason, we just have to repeat this keyword so that the length of the keyword or the length of the key becomes same as that of the length of the plain text. For that reason, here you can see that the deceptive keyword is repeated thrice to make it as of the same length of the plain text. Now in the next slide, I'll explain you how the ciphertext is achieved using the plain text and the key. Now here, we'll be seeing how the basic functionality of the Vigenere cipher is. What terminology or what methodology the Vigenere cipher uses to convert the plain text into the ciphertext when the keyword is given. The Vigenere cipher uses 26 into 26 table with A to Z as the row heading and the column heading. This table is usually referred to as the Vigenere tableau or the Vigenere table or Vigenere square. Here we are considering it as a Vigenere table. So here you can see that the first row of this table has 26 English letters, 26 English alphabets which we use in our day-to-day life. Starting with the second row, you can see that each row has the letters shifted to left one position in the cyclic way. That means the first row starts with the alphabet A, ends with the alphabet Z. But the second row starts with the alphabet B and ends with the alphabet A. That means in every next row after the first row, one letter is shifted to the left by following the cyclic way. Similarly, the third row, you can see the third row is starting with the letter C and it is ending with the letter B, followed by D ending with the letter C, E ending with the letter D, F ending with the letter E, so on. And the last row, that is the Z, it is starting with the letter Z, which is ending with the letter Y. So in this way, 26 into 26 Vigenere table we get. Now we will see how to use the letters in the keyword and the letters of your plain text. So here we have the plain text as we are discovered, save yourself, and the key is deceptive. So just keep in mind that the first letter of the plain text is W and the first letter of the key is letter D. Now, how the ciphertext how we will get the ciphertext and how we will convert the plain text into ciphertext, we'll see in this slide. You have to just follow the tradition by removing all the spaces. These are actually the prerequisites which has to be done before converting your plain text into the ciphertext. What we have to do is we just have to remove all the spaces and punctuations, converting all the letters in. We just have to convert this letters into the uppercase. I forgot to do that. And what we have to do is we just have to divide the plain text and the keyword into 5-letter blocks. Okay, so we have converted the key 5-letter, 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 plain text 5-letter, 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 which is at the end we are left with only the 2 letters. Now to encrypt, what we have to do is we just have to pick a letter in the plain text and its corresponding letter in the keyword. Use the keyword letter and the plain text letter as the row index and the column index respectively. What we have to do is we just have to use the keyword letter, that is the letter D, as the row letter and the plain text letter, that is the letter W, as the column letter. And then we have to look into that big matrix. Now here you can see with the arrows, the letter D is being considered as the letter for the row, and the letter W is being considered as the letter for the column. And the ciphertext letter for this combination will be the letter Z. That is the letter where the row and the column is intersecting. So that intersecting alphabet then can be considered as the ciphertext for those respective keyword letter and the plain text letter. Again, if we consider the next letter, that is the next letter in the keyword is E, and the plain text also the next letter is E. So how we will be doing for this? The row letter is E, the column letter is also E, and the intersecting alphabet which we are getting it as the I. So the ciphertext for this combination we get it as I. So in this way you have to proceed for the complete length of the plain text message, and then you can get your ciphertext as for D row column and W column wise. If we see the intersecting point was the Z, for the second alphabet of the key and the plain text the intersecting point was I, and in the same manner you have to repeat the steps for all the letters in your plain text and the keyword, and in such a manner you can get your ciphertext. That means when we will be repeating these steps. So here you can see that the next combination where we are getting the keyword alphabet as E and the plain text alphabet as R. So though the keyword letter is same, that is what we had in the second step E, now in the fourth step also we are having the same letter as E, but for that the column would be different, and for that reason the intersecting point will be different. And that is why it is said that in the polyalphabetic cipher we are using multiple ciphers at the same encryption technique, and that is why it improves the security of the polyalphabetic cipher, or we can say that it improves the security of the Vigenere cipher. So security of Vigenere cipher, as it has multiple cipher letters for each plain text, this obviously increases the security of the Vigenere cipher. I have already told you what the reason is. Hence the letter frequencies are obscured, like letter frequencies are unnoticed by any of the attacker, but not totally lost. It is not the case that if any attacker really wants to breach this, then that attacker can work upon it. We have to just start with the letter frequencies. If not, they need to determine the number of alphabets, since then can attack each separately. If some attacker wants to attack, then that attacker has to work upon the blocks, as we have divided this into 5-letter blocks. So if a attacker works upon the blocks, and if the attacker wants to breach in the security of the Vigenere, it can be, but it then becomes impossible, or it then becomes very, very difficult for the attacker to breach the security of such type of the polyalphabetic ciphers. Hope you might have got this. Thank you.